So we have been doing this for the past like 2 weeks already. And what is the beauty is this analysis, regardless of how the structure is loaded, the head of the arrow is compression, the tail is tensor, is a generic solution. Okay. So the next thing that we are going to find moment about y. Oh, sorry, moment about z. Before I go on, any questions so far? Thank you.
Hi, Eugene.
Yes.
Should this moment y be lib inches, like pound inches?
Oh yeah, you're right. Yeah.
And my other question being like, isn't the standard pound foot pounds? And so should we be doing 2/12?
2/12.
Like, should we be converting our inches to feet because the standard unit in imperial is foot pounds?
No, it's pound inch.
Not pound sorry, I'm
feet.
just mistaken then.
No, does not matter. Wait, not does not matter because our stresses, our use strength is pound per square inch. Yes or no? So we have to use pound inch. If your stresses are given in pounds per square feet, you use pound feet. You get where I'm coming from? Yes or no?
I see. Thank you.
Right, that makes sense. Yes. Right. Thank you for I missed out. Yeah. So over here, next we're going to find moment about. We're going to find moment in the z direction. So again, my thumb is pointing in this direction. So you grip with right hand rule. So this is your mz. I'm going to have mz positive in that direction. So the next thing is, what is a perpendicular distance? As I said, the perpendicular distance is the one that most of us, or even I, make a lot of mistake. So this is our perpendicular distance now, right? Right, this is 90 degrees, this is perpendicular distance, and this is 0.9 inch. Okay, so I've been teaching this. This is my 4th year teaching this structural engineering mechanics. A lot of times students make mistake in getting the moment. So I want you to make it like foolproof for yourself. So that's why I'm drawing separate diagrams so you know that you take my, what is your perpendicular distance, mz, what is your perpendicular distance. So from here, mz will be equal to the 150 is going to cause a clockwise rotation or the opposite rotation from what is positive. So minus by 150 multiplied by 0.9 and then plus by 500 multiplied by 0.9. There's 0.9 and then plus by 250 multiplied by 0.9. So what we have over here is minus 135, then plus by 450, and then plus by 250 multiplied by 0.9 upon 250 is equal to 225. So from here, again, you're going to get a positive value, means the assumed direction is correct. So you have 540 pound inch, and we know that the moment direction is going this way. Okay, so we can immediately put this in. This is how your moment about z will be acting. So down here will be compression, down here will be tensile. Right? So what we want to calculate now is we want to calculate the stress. So there are points that they are given. This is point A, and then we have our point B, and lastly we have our point D. So we want to calculate our stresses at point A. Right? Before we do that, we also need to calculate our second moment of area. All right. So second moment of area. So we're going to calculate. I'm going to use a new page. So we're going to calculate second moment of area. So we want to calculate IYY first. So some of you say, oh, here we go again, right? So IYY, when I say here we go again is, yeah, you can get this mixed up really easily. So in our YY axis, so if you look over here, our YY axis, this is our YY axis, right? YY. So like what I've taught you guys before, parallel to the axis is the width, perpendicular distance. This will be the what? Depth relative to the axis. So you will have IYY is equal to the width is 1.8, and then the depth is 4 cubed divided by 12. So the outcome of this is 4 power 3 times by 1.8 divided by 12. So it's 9.6 inches to power 4. Then I will do by the side. You can compare for yourself. So this is IZZ, right? So again, identify which is the width and which is the depth. It's very easy if you know, if you do it relative to your axis, right? So ZZ over here now, this is your ZZ. So when there's a case, the geometry that's parallel now becomes the what? The width. And then when it's perpendicular to the axis, this is the what? The depth. So immediately you can specify IZZ is equal to the width, depth, cube divided by 12. So this is equal to 1.8 power 3 times 4 divided by 12 is 1.944 inch to power 4. Right, now we get all this iron out, and the last thing that we need to calculate is the area. So the area is equal to 1.8 multiplied by 4. So this is equal to 7.2 inches squared. All right. So now we can start assembling the entire equation already. Right. So we'll copy what we had before. I'll take this image. And I'll also incorporate the moment about Z. Oh, sorry, moment about Y. So we know that this is our moment about Y. So moment about Y, this will be compression. And this will be tensile. And an important thing to draw, if you could, you have to specify what is your Y distance. And this is your Z distance, okay? So this is Y, and this is Z. And I'll tell you why later on, why we have to, sorry, this is our Z. And this is rotation about X. I'll tell you why this diagram is so important. So the first thing we want to find is stress in the X direction at point A. So this will be equal to Px divided by A. Then you have your My over Iyy multiplied by Z. And then Mz over Izz multiplied by Y. So if we were to look at point A now, if we were to focus at point A now, right? If we look at point A now, so this is our point A. And then My is going to cause a tensile. You can see it over here. My is going to cause a tensile. So you just put positive down here. And then Mz, you look at Mz, at point A is going to induce a compression. Okay, it's induced a compression. Then that's where we know that we're going to put the minus sign. That's why I say don't worry about the sign. Once you got the vector right, do not worry about the signs. Okay, so Px which we have calculated. So our px is equal to 900. Right, 900 divided by our cross-sectional area, which is 7.2, plus by my. So we have calculated our my, which is equal to 800, and divided by our iyy, which is 9.6. Now, this is where it gets confusing. Z, right? So once you analyze it, when you look at this, when you look at this diagram, right, your mind is already thinking so much. Then you're like, Z distance. What is this Z distance? That's why this diagram over here, what I mentioned, this is critical. You know, Z is in that direction. Yes or no? Z is in that direction. That's why this transformation is important. So you know Z is that direction, right? So you know that Z relative from IYY, right, in Z direction is equal to what? 2. Okay, so a lot of times student makes a mistake like this. I also did the same way when I was undergrad, right? So I'll do it again, minus by MZ. So we calculate MZ to be 540, and then divide by IZZ 1.944, and then the Y distance. So you're like, where's the Y distance? So you look at Y distance, right? So Y distance is parallel to the Y axis, so it's equal to what? 0.9. So once you get this, so 900 divided by 7.2 is equal to 125, plus by 800 times 2 divided by 9.6. So it's equal to, 500 over 3 minus by 540, 1.944, 250. So this will be equal to 41, positive 41.667 psi. Okay. So as I said, the critical part is where we tend to make mistake with this value over here. And also we tend to make mistake with this value over here. Okay, so that's why it's important for you to draw this transformation out so you can visualize better. Right, so the next thing that we're gonna, so far, before I go on, any questions so far? Are you okay? We're fine? Anyone? Any questions so far? Nope. Okay, so the next thing that we're going to do now, we're going to look at stress X at point D now. Okay, we're going to find stress X. Stress X at point D. So stress X at point D. So we are aware that the structure is symmetry. Okay, so if we look at stress D now, which is what we're interested over here, is this point over here that we're interested now. So we will have Px over A. So the formula is still the same. So we're going to write down Px. So I will write this down. So it's Px over A. Again, My over Iyy multiplied by Z. And then we have Mz over Izz multiplied by Y. Okay. So at point D is where we're interested. So if we look at My now, we look at moment about Y. At point D, right, point D, so this is point D, at moment about Y, right, is going to induce a compression. So My, so you put a negative sign over here, and then Mz, so Mz, like what you can see over here. So this is your Mz at a point D is going to be what? Tensile. Oh, I do apologize. I should not highlight with pink. Okay, sorry, I'm partial colorblind also. So we know that this is tensile. So this is going to be plus. And the Z distance, right? If you look at point D, the Z distance is also 2. And the Y distance is also 0.9. So what I'm trying to highlight, you can still use the same number like before. So you have 125. So now minus 500 over 3. And then plus by 250. So the outcome, So 125 minus 500 over 3 plus by 250. So it's equal to 208. Hold on. 125 minus 500